what I'd like to do here is I'd like to go over a two-dimensional momentum problem. We're going to do page 44 on, number 44 on page 194. We'll read this problem here, set up a before and after picture, and then talk through how to do that. So, I'm reading here. Billiard ball A with a mass of 0.12 kilograms, moving at a speed of 2.8, the point there, meters per second, strikes ball B initially at rest of mass 0.140 kilograms. As a result of the collision, so now I'm going to draw my after picture. As a result of the collision, ball A is now going to be deflected off at an angle of 30 degrees. So 30 degrees with a VA prime of 2.1 meters per second. And it's asking me, taking the x-axis to be the original motion of the ball, write down equation expressing conservation of momentum of the components in the x and y direction separately, and solve these equations for the speed VB prime. So this other ball goes this way. We know it goes this way because the y momentum has to cancel out the y momentum of A here. So it has to go down instead of up. So this is ball B, and we want to figure out what's VB prime and what's this angle, which we could call theta B prime. Alright, if this were a regular one-dimensional conservation of energy problem, we'd just say sum of P equals sum of P prime. But we can still do this, it's just these are now vectors, they're not scalars. So we can say that the momentum of A plus the momentum of B equals the momentum of A prime plus the momentum of B prime. And if you recall, the way that we deal with vectors is if we've got a vector equation, that can resolve itself into two separate component equations. Well, when we say PAX plus PBX equals PAX prime plus PBX prime, and the other where we have PAY plus PBY equals PAY prime plus PBY prime. Okay, now let's talk about these. So basically we've got to be talking about momentums. So what I want to do here is I'm going to, up here I'm going to calculate what my PA is. And we know that our PB, since VB is 0, we're going to say our PB is also 0. Now I could plug in numbers in here, but I'm going to pull out a calculator here, and I'm going to try and save us from making this problem into too big of a mess. If I do 1.120 times 2.8, I'm getting 0.336 kilogram meter per second. And let's look at what this one is. This PA prime would be the mass of A times, I'll show you my calculator here, times the velocity of A. So 0.252. So this is actually helpful too because if we think about this in terms of an axis where it says it wants us to treat this as the x-axis going this way. So here's our x-axis and here would be our x-axis here. We could say that this is all, PAX is all in that direction and that the PAY is 0 because it's not going up and down. Likewise, too, PBX is 0 and PBY is also 0. Okay, how are we going to do that here, though? Well, whenever we got something that goes at an angle, we want to resolve it into components. So we could say that the sine of 30 equals, in this case, PAY over PA. Those are primes. And the cosine of 30 equals PAX over PA. So I think by doing that, I'm getting a PAY of 0.126 and a PAX of cosine 30.218. And now it's just a plug and chug problem, right? So PAX here is 0.336 plus PBX is 0. PAX prime is 0.218. We want to find PBX prime. And similarly, we got 0 plus 0 equals PAY prime 0.126 plus, stupid hole there, PBY prime. So we get then that this object here, object B, is going in this direction with a PBX of, what would that be? 0.336 minus 0.218. So we got PBX prime being 0.118 kilogram meter per second. And here we got PBY being negative 0.126 kilogram meter per second. And that's a triangle. We know how to deal with triangles. A squared plus B squared equals C squared. I'm getting that this comes out to be 0.173 kilogram meter per second. So now that's the P. Well, then let's get the angle while we're at it. So arctangent of 0.126 over 0.118, I'm getting 46.9 degrees for an angle here. So we can say now that the P prime of B as a vector is 0.173 kilogram meter per second at 46.9 degrees south of east. It doesn't want PB though, it wants VB. So the last step is P equals MV. So 0.173 equals, what's the mass of B? 0.140 times V. So I should get 1.23 meters per second at, it's going to be the same angle, 46.9 degrees south of east. So again, a little bit of a mess, but conceptually this is really no different than anything else we've done, right? This is regular conservation of momentum. We're just adding two-dimensional stuff from last semester to it.